When I first learned that humans haven't been around for very long, it was kind of shocking. I mean, we feel like we've always been here, don't we? Everywhere you look, there are people, cities, machines, and noise. But if you imagine the Earth's history as a giant calendar, with January 1st being the very beginning of the planet, humans don't show up until the very last day, almost at midnight. That means for nearly all of Earth's story, there were no humans at all. And that got me wondering, if we weren't there, who was? That's how I stumbled into the strange, wild world of the Miocene epoch. It sounds like a fancy word from a science book, but it was just a slice of time about 23 to 5 million years ago. Back then, the Earth didn't look quite like it does today. The continents were still shifting into their modern places, and the climate was different, too warm in some eras, cooler in others, but full of forests, grasslands, and life moving in new directions. The Miocene was like a rehearsal for the world we live in now. It's when grasslands spread widely across continents, when new kinds of animals tried out their survival strategies, and when apes, yes, apes really began to shine. Now, when I say apes, you might think of chimpanzees or gorillas or maybe orangutans swinging through trees. But during the Miocene, the ape family was way more diverse. Imagine dozens of different species, some big, some small, living in Africa, Europe, and Asia. They weren't exactly like the apes we know today, but they weren't like monkeys either. They were something in between, experiments of nature, if you want to think of it that way. And hidden among them might have been one species that eventually led to us. That's the part that gives me goosebumps, knowing that long before there was history, before there were tools, before there was fire or language, there might have been a single ape species that carried the spark of what we'd eventually become. The Miocene world wasn't calm and quiet. It was wild. Forests stretched across parts of Africa and Europe, filled with creatures we'd find strange today. There were elephant-like animals with 4 tusks, ancient relatives of horses that were smaller and with more toes, and strange horned beasts that don't exist anymore. It wasn't just about apes evolving, everything was. The planet itself was rearranging life in slow motion. And while all this was happening, apes climbed, leaped, and explored the trees above, trying to survive in a changing world. When I first read about these Miocene apes, it felt almost like opening a mystery novel. Fossils were the only clues left behind, buried in layers of rock. And scientists had to piece them together, bone by bone, tooth by tooth, to figure out what these animals looked like and how they lived. Imagine finding a jaw with huge teeth and trying to picture the face it belonged to. Or discovering a piece of skull and guessing whether it belonged to an ape that walked mostly on 4 limbs, or maybe sometimes upright, like us. Each fossil was like a puzzle piece from a story almost lost to time. The reason this time period is so important is because of one huge question: where did we come from? Not just humans in general, but the very first ancestors that made us different from other apes. Scientists believe that during the Miocene, somewhere among all those ape species, was the ancestor that would eventually lead to humans. But the tricky part is we don't know which one it was. Some think it could have been Proconsul, an early ape that lived in Africa about 20 million years ago. Proconsul didn't look much like a human, but it had features that suggested it was already different from monkeys, like the way it lacked a tail and had more flexible movement. Then there were others like Graecopithecus in Europe, with long arms and traits that reminded scientists of modern apes. And then there was Ouranopithecus, found in Greece, with powerful jaws and teeth that made people wonder if it was closer to our direct line. All of these apes tell a part of the story, but none of them give the whole answer. That's why the Miocene feels like a grand mystery full of suspects, but no clear culprit. What fascinates me the most, though, isn't just the science part. It's imagining what it would have been like to stand in a Miocene forest, 10 million years ago. The air would have been heavy with the smell of plants and earth. Strange bird calls would echo through the trees. Herds of ancient animals might rumble across the grasslands nearby. And somewhere above, an ape, maybe the one that started it all, would be clinging to a branch, chewing on fruit, with no idea that its descendants would one day build airplanes, rockets, and skyscrapers. I sometimes close my eyes and think about how that ape, whatever species it was, lived its ordinary life. It wasn't special in its own time. It was just trying to survive like everything else, avoiding predators, finding food, caring for its young. It couldn't have known that millions of years later, kids like me would be sitting in classrooms learning about its bones. But that's how history works. The biggest turning points don't feel big when they happen. They only look big when we look back. So part 1 of the story is really about setting the stage. The Miocene was the testing ground. It was when apes began to branch out, when climates pushed animals to adapt, and when the first sparks of us were hidden in the lives of creatures that didn't even know they were special. And somewhere, maybe in Africa, maybe in Europe, an ape lived that might have been the beginning of our story. That's the thought I can't shake, that one day, millions of years ago, the chain of events that would lead to human history quietly began in the life of an ape that had no idea what was coming. When I think about the Miocene, I don't just imagine the apes. I try to picture the whole world they lived in. Because if you really think about it, no creature exists in isolation. We're all shaped by the land beneath our feet, the plants that grow around us, the climate that surrounds us, and the other animals we share space with. And during the Miocene, the world was busy changing, almost like nature was preparing the stage for the story of humans, without even knowing it. The Miocene started around 23 million years ago and lasted until about 5 million years ago. That's almost 18 million years, a huge stretch of time. To us, it feels impossible to imagine. A million years already sounds endless, but 18 million? That's more than enough time for mountains to rise, seas to shrink, forests to spread, and animals to appear and vanish. And the Miocene had all of that. One of the most important things happening was the shifting of continents. Africa, which had once been separated, kept bumping into Europe and Asia. This collision didn't happen quickly, it took millions of years, but the effects were massive. New land bridges formed, animals migrated between continents, and whole ecosystems were reshaped. Imagine herds of animals wandering from Africa into Europe, or apes exploring new forests they'd never seen before. These migrations didn't just mix up the animal populations, they also spread plants, seeds, and even shaped climates. And speaking of climate, the Miocene had its moods. In the early part, it was generally warm, with lush forests stretching across much of Africa, Europe, and Asia. Apes thrived in these forests. They swung, climbed, and leapt between branches, living off fruits, leaves, and whatever else they could find. But as time went on, the earth began to cool. By the middle and late Miocene, forests started to thin in some places, giving way to open grasslands and savannas. That might not sound dramatic, but it was a huge deal. If you're an ape built for climbing trees, what do you do when the trees start to disappear? Some adapted. Some moved. And some faded into extinction. I sometimes imagine walking across a Miocene savanna. The ground is dotted with patches of tall grass, and scattered trees stand like lonely umbrellas under the sun. Herds of grazing animals, ancient relatives of antelope, horses, and even camels move in groups, alert for predators. Strange elephant-like creatures with 4 tusks roam nearby, using their trunks to pull up grasses. And in the distance, you might spot a small band of apes sticking close to the trees, climbing up for safety whenever they feel threatened. What's interesting is that the Miocene wasn't just about apes. It was about everything evolving together. The grasses themselves were a kind of revolution. They spread across huge areas and became the foundation for new food chains. Animals that could eat grass thrived, like early horses that were small and had multiple toes. Over time, these horses evolved into faster runners with single hooves, perfect for outrunning predators in open plains. Predators, of course, had to evolve too, becoming quicker, sharper, and better hunters. It was an arms race of survival, and apes were caught right in the middle of it. For the apes, the forests were both home and safety net. But as the forests shrank, they had to face new challenges. Did they climb down more often to search for food on the ground? Did they start walking differently, even if only a little? Did they compete with monkeys, who were also spreading widely during this time? Fossils don't give us every detail, but they leave hints: the shape of a limb bone, the wear on a tooth, the curve of a spine. Sometimes I picture a young Miocene ape, clinging to its mother as she moves through the branches of a thinning forest. They're searching for fruit, but it's harder to find than it used to be. Below them, the grasslands stretch farther than ever before, filled with animals the apes don't usually interact with. Maybe, for a moment, the mother climbs down to the ground and moves carefully through the grass, carrying her young. Maybe she feels exposed, nervous, but determined. Little does she know, this kind of cautious exploration might be the beginning of something bigger, the first steps toward a way of life that would eventually define us. One thing I find really cool is how scientists can actually read the past climate from fossils and rocks. For example, the teeth of grazing animals tell us what kind of plants they ate. The layers in ocean sediments record changes in temperature. Even tiny bits of fossilized pollen can reveal what kinds of trees or grasses grew in a region millions of years ago. Piece by piece, it all comes together like a detective story. And when scientists reconstruct the Miocene world, what they see is a time of transition. Forests to grasslands. Warmth to coolness. Isolation to connection between continents. It was a world in motion, and motion means opportunity and risk. And this shifting world mattered deeply for apes. In Africa, early apes like proconsul thrived in forested environments. But as some forests gave way to open woodlands, apes had to adapt or vanish. In Europe, apes like Graecopithecus found niches in spreading forests, while others, like Ouranopithecus, lived in environments that were drier and more open. Asia, too, saw its own apes, like Sahelanthropus, which shared traits with modern orangutans. Each species was trying out a different strategy, almost like nature was running experiments. What if apes had stronger jaws for tougher food? What if they had longer arms for climbing? What if they could handle drier environments? Some of those experiments failed, leaving only fossils behind. But some carried forward traits that would eventually be part of us. When I think about it, it's kind of humbling. We often think of evolution as this straight line leading to humans. But the Miocene shows us it was more like a tangled tree, with branches growing in all directions. Some branches ended, some kept going, and one branch, just one, eventually led to us. And that branch grew in a world that was constantly changing, forcing every creature to adapt. I remember once looking at a globe in class and spinning it around. My teacher said the continents hadn't always been in those spots. In the Miocene, they were still shifting, and that's why animals could move between Africa, Europe, and Asia. Without those shifts, maybe apes wouldn't have spread the way they did. And if they hadn't spread, maybe we wouldn't even be here. It's wild to think that something as huge as the drifting of continents could influence something as personal as our own existence. So when I imagine the Miocene world, I don't just see an ape in a tree. I see a stage that was noisy, crowded, and full of constant change. A stage where grasses spread like wildfire, where herds thundered across open plains, where predators lurked in shadows, and where apes clung to survival in forests that weren't as safe as they used to be. And somewhere in that shifting, restless world, the path toward humans quietly began. That's the thing about the Miocene, it wasn't just about apes living their lives. It was about the world preparing, in a way it didn't even know, for one of its strangest future experiments us. If you were reading a detective story, this is the moment when the first suspect walks into the room. You don't know yet if they're guilty, but they look interesting, maybe even a little suspicious, and you can't help but study them closely. In the great mystery of human origins, that first suspect is an ape called proconsul. The name sounds kind of fancy, almost Roman, but it really just comes from the way scientists in the 1800s liked to name fossils. Proconsul means before consul, and consul was the name of a famous performing chimpanzee in a London zoo. So proconsul was named because it seemed like something that came before a chimpanzee, an ancient cousin, living long before humans or chimps or gorillas. Proconsul lived in Africa around 20 to 18 million years ago, which makes it one of the earliest known apes. That's important, because Africa was and still is the birthplace of many of our ancestors. When scientists first uncovered its fossils, they realized they were looking at something that didn't quite fit the categories they knew. It wasn't a monkey, but it also wasn't a modern ape. It was something in between, a bridge from one world to another. So what did proconsul look like? Imagine an ape about the size of a medium dog, depending on the species. Some proconsuls were small, maybe the size of a cat, while others could weigh as much as 100 pounds. They had no tails. That was a big clue that they weren't monkeys. Their arms and legs were more equal in length than those of modern apes, suggesting they walked on all fours along branches, not swinging dramatically like gibbons or chimpanzees. Their hands and feet were adapted for gripping, perfect for climbing, but their posture was more cautious and balanced, not the kind of knuckle walking we see in gorillas or chimps today. The most telling parts, though, were in the skull and teeth. Proconsul had a rounded skull with forward-facing eyes, much like modern apes, and its teeth showed a diet that included fruits, a clue to its forest home. Fossil teeth often preserve tiny scratches or patterns that reveal what an animal ate. In proconsul's case, the patterns suggested it was munching on soft fruits, maybe mixed with leaves and seeds. When I imagine proconsul, I don't see some heroic figure starting humanity's journey. I see a careful creature moving along a tree branch in an African forest, scanning for ripe fruit. Maybe it pauses, lifting its head to listen for predators, before dropping down to another branch. Its young cling tightly as it climbs. Life for proconsul was about survival, nothing more, nothing less. It had no idea it would one day be studied as a possible ancestor of humans. The fossils of proconsul were first found in Kenya in the 1900s, and later discoveries filled in more details. The East African Rift Valley, with its exposed layers of ancient rock, became one of the richest fossil treasure chests in the world. Scientists uncovered not just proconsul, but other early apes and mammals, showing how life was experimenting in the warm forests of the Miocene. Proconsul quickly became famous because it gave scientists their first real glimpse into what early apes might have looked like. Now, here's the interesting part: scientists aren't all in agreement about Proconsul's place in the family tree. Some think it could have been close to the common ancestor of all modern apes and humans. Others believe it was more of a side branch, an early experiment that didn't quite lead to us. Fossils don't always give us neat answers. They give us clues, and the rest is about connecting dots. Think of it like this: if evolution is a giant family tree, Proconsul might be near the trunk, where the first big branches split. From that trunk, one branch led to today's monkeys, while another led to apes and humans. Proconsul sits right around that important fork, which is why scientists study it so carefully. Even if it wasn't our direct ancestor, it was very close to the starting point of the line that eventually produced us. And here's what really excites me: Proconsul's world tells us about the conditions that shaped early apes. In the early Miocene, Africa was covered in rich forests, perfect for tree dwellers. Proconsul thrived in this environment, moving cautiously across branches, eating fruit, and raising young. It didn't need to swing far or walk upright. It had no reason to. The forests were thick, the food was plentiful, and survival meant staying up in the trees. But as millions of years passed, climates shifted, and forests thinned. Apes that had once lived like Proconsul had to adapt to new conditions. Some developed stronger jaws for tougher foods. Some became better climbers. And maybe, just maybe, some began experimenting with life closer to the ground. In that sense, Proconsul is like a snapshot of the before picture, showing us what apes looked like before the world started changing in ways that would eventually lead to us. I like to imagine what a day in Proconsul's life might have been like. The sun rises over a Miocene forest in East Africa. Mist clings to the trees as bird calls echo through the canopy. A group of Proconsuls stirs from their sleeping spots, stretching and moving along the branches. They search for figs and other fruits, sharing space with early monkeys, birds, and small mammals. Occasionally, a shadow below, maybe a predator, reminds them why the trees are safer than the ground. The group communicates with chirps or calls, warning each other of danger or signaling where food is found. To us, it might seem simple. But to them, it was life. Every decision when to climb, when to eat, when to hide was about survival. And in those ordinary choices, the seeds of our extraordinary future were buried. What makes Proconsul so fascinating is how ordinary it was. It wasn't walking upright. It wasn't making tools. It wasn't almost human in any obvious way. But it had the right combination of features: no tail, flexible movement, forward-facing eyes, grasping hands that marked it as part of the lineage that would, much later, produce apes like chimpanzees, gorillas, orangutans, and, eventually, us. It was a small step, but in evolution, small steps add up over millions of years. I sometimes think of Proconsul as the quiet beginning of a story. If the Miocene is a stage, Proconsul is one of the first actors to walk out, setting the scene. Its role might not have been dramatic, but it was important. Without creatures like Proconsul, the later apes, the ones that look even closer to us, might never have existed. So was Proconsul the one that started it all? Maybe. Maybe not. The truth is, we may never know for sure. But it was close enough to the root of the ape family tree that it deserves our attention. It's the first suspect in the mystery, the first clue in the puzzle, the first hint that somewhere in these forests of ancient Africa, the story of humans was beginning. And that's what keeps the mystery alive. Because if Proconsul was only the first suspect, then we have to keep looking for others apes that lived later, in different environments, facing new challenges. The trail doesn't stop here. It's only just beginning. When I think about detectives chasing mysteries, there's always that moment when a new suspect appears, someone who suddenly makes the case even more complicated. That's exactly how I feel about Dryopithecus. If proconsul was the first big clue in Africa, Dryopithecus was the next one, except the suspect didn't live in Africa at all. It lived in Europe. And that changed the story in ways nobody expected. Dryopithecus lived about 12 to 9 million years ago, millions of years after proconsul. By that time, the Earth had already been reshaped by the shifting climates of the Miocene. Forests still existed, but they were patchier than before. Grasslands were spreading, and apes were adapting to different kinds of environments. While some apes stayed in Africa, others made their way into Europe, where Dryopithecus appeared. The name Dryopithecus means tree ape, which is a pretty good description of its life. Fossils of Dryopithecus have been found in places like France, Spain, and Hungary, showing that Europe wasn't just home to strange elephants and ancient horses, but also to apes living in its forests. And these apes weren't just tree climbers, they shared traits that look surprisingly like the great apes we know today. So what made Dryopithecus stand out? For starters, its body. Unlike proconsul, which had more equal length arms and legs, Dryopithecus had longer arms than legs, a sign that it was adapting for more advanced climbing and swinging. That's a feature we see in modern apes like chimpanzees and orangutans. Its fingers were long and curved, perfect for gripping branches, and its shoulder joints were flexible, allowing it to move in ways monkeys couldn't. These details told scientists that Dryopithecus wasn't just walking along tree branches like proconsul. It was hanging, swinging, and climbing with a skill that looked much more like today's apes. Its skull and teeth were equally fascinating. Dryopithecus had a relatively large brain for its size, though still nowhere near human levels. Its teeth suggested a diet of fruits and leaves, showing that it lived in forests where food like that was available. But what really caught scientists' attention was how much it resembled living apes. When they looked at the fossils, they saw similarities to chimps, gorillas, and even humans. It was almost like Dryopithecus was a missing puzzle piece, not the whole picture, but close enough to hint at what was coming. Now here's where the story gets tricky. When fossils of Dryopithecus were first studied in the 1800s, some scientists thought they had found direct evidence that humans came from Europe. After all, if Dryopithecus lived in Europe and looked so much like the ancestors of modern apes and humans, maybe that was where our story began. For a while, this idea was very popular. People imagined forests in Europe as the birthplace of humanity, with Dryopithecus as one of the key ancestors. But as more fossils were discovered, especially in Africa, the picture became more complicated. Scientists realized that while Dryopithecus was important, it might not have been directly on the line to humans. Instead, it might have been more closely related to African apes like chimpanzees and gorillas, or maybe even a side branch that eventually died out. The truth is, nobody knows for certain. Fossils don't come with labels saying future ancestor of humans. They just sit there, leaving us to piece the puzzle together. I like to imagine Dryopithecus in its European forest. It's early morning, and the light filters through tall trees. A group of these apes moves high above the ground, gripping branches with their long fingers. They're quieter than monkeys, more deliberate in their movements. One reaches for a cluster of fruit, while another swings carefully to a nearby tree. On the ground below, herds of grazing animals move through clearings, while predators lurk in the shadows. The apes stay high, where they're safest, their lives centered around the rhythm of the forest canopy. What's really fascinating is how Dryopithecus shows us that apes were spreading far and wide during the Miocene. It wasn't just Africa anymore. Europe had its own apes, Asia had its own too, and each group was experimenting with different ways of living. In a way, it was like evolution was running multiple trials, testing which features worked best. Long arms for climbing? Strong jaws for tougher food? Bigger brains for problem solving? Some traits stuck, some didn't. But the point is, there wasn't just one path forward. There were many, branching out in all directions. When scientists study Dryopithecus, they pay close attention to its similarities to modern apes. For example, the shape of its teeth and jaw look closer to African apes than to monkeys. Its face, too, had features that remind people of chimps. But then again, it wasn't identical. It had its own unique mix, which is why it's so hard to place it exactly in the family tree. Was it an ancestor of gorillas? Of chimps? Of humans? Or was it simply a cousin that shared some traits before going extinct? That's the thing about the Miocene, it doesn't give us clear answers, just fascinating possibilities. Each new fossil discovery has the power to shift the story. When Dryopithecus was first found, it looked like the key ancestor. Later, when more African fossils appeared, it seemed less certain. And even now, debates continue. Some scientists argue Dryopithecus might have been closer to the line leading to African apes and humans, while others think it was just another branch of the family that didn't survive. I remember reading once that history is written by survivors. That's true for evolution too. The only reason humans are here to wonder about the past is because our branch survived while so many others didn't. Dryopithecus didn't make it, but it left behind clues that help us understand how apes evolved. And that makes it a vital part of the story, even if it wasn't the one that started it all. For me, Dryopithecus feels like the moment in the mystery when you realize the story is bigger than you thought. It's not just Africa. It's Europe too. It's not just one possible ancestor. It's many, overlapping, and competing. The stage wasn't small, it was global. And Dryopithecus, hanging in the forests of Europe, was one of the key players. So if proconsul was the quiet beginning, Dryopithecus was the dramatic twist, the ape that looked more like modern apes, the fossil that made scientists wonder if Europe might hold the answers. It was a suspect that didn't just complicate the story, it expanded it. And even if Dryopithecus wasn't our direct ancestor, it showed just how diverse and widespread our ancient cousins were. And that brings me back to the central question: who was the Miocene ape that might have started it all? Proconsul gave us the first hints. Dryopithecus brought us closer to modern apes. But the mystery is far from solved. There are still more suspects waiting in the wings: apes that lived in Asia, and others that survived in drier, harsher environments. And one of them, maybe, just maybe, was the true beginning of us. When you're reading a mystery story, there's always that suspect who makes you sit up straighter, the one who seems more convincing than the rest. For me, in this grand puzzle of the Miocene, that suspect is Ouranopithecus. Even the name sounds weighty, like it belongs to something important. Ouranopithecus means ape from the heavens, because its fossils were discovered in Greece, and Ouranos is the Greek word for sky or heaven. To me, it feels like the name alone gives it a special place in the lineup of suspects, not just another forest ape, but one that carries a little more mystery, a little more connection to us. Ouranopithecus lived around 9 to 7 million years ago, much later than proconsul and even after Dryopithecus. That timing matters. If proconsul was like the earliest chapter and Dryopithecus was the middle twist, then Ouranopithecus was close to the climax of the Miocene story. By the time it lived, the Miocene epoch was already winding down, and the world was shifting towards something new. Forests were shrinking even more, climates were becoming cooler and drier, and apes that couldn't adapt were disappearing. In the middle of this changing world, Ouranopithecus stood out. The first fossils of Ouranopithecus were found in Greece in the 1970s, with later discoveries in other parts of southeastern Europe. What scientists uncovered were mostly skulls and jaws, but what jaws they were. Ouranopithecus had a massive, powerful face, with thick, strong teeth built for chewing tough foods. Imagine wide molars, thick enamel, and jaws that looked ready to crush hard plants or fibrous roots. This wasn't an ape that lived only on soft fruit. It was an ape that could survive on harder, drier foods in more challenging environments. And that's part of what makes it so fascinating. Unlike Dryopithecus, which lived in lush European forests, Ouranopithecus lived in more open, drier habitats. Picture woodlands mixed with grasslands, a place where fruit wasn't always easy to find. In that kind of world, you needed stronger jaws and tougher teeth to survive. Ouranopithecus had exactly that, a mouth that could handle whatever nature threw at it. But it wasn't just the jaws that caught scientists' attention. The shape of its face, broad, with a flatter profile compared to some other apes, reminded people of early hominins, the group that includes humans and our direct ancestors. That similarity set off a wave of excitement. Could Ouranopithecus be more than just another Miocene ape? Could it be the one closest to us? I like to imagine Ouranopithecus in its world. It's a hot day in late Miocene Greece. The forests are patchy, with stretches of dry grass between them. A group of Ouranopithecus moves slowly, searching for food. One pulls up a tough root from the ground, biting into it with its powerful jaws. Another climbs into a tree to reach leaves and maybe a few clusters of fruit. They're not as nimble as gibbons, not as huge as gorillas, but they're sturdy, built for endurance in a world that was getting harder to live in. Their eyes watch the horizon carefully. On the grasslands nearby, strange antelope-like animals move in herds. Predators lurk somewhere out there, but the apes stay close to the trees. When scientists study the fossils of Ouranopithecus, they notice more than just jaws. They see hints that it might have shared other traits with early hominins. For example, its teeth had thick enamel, like ours, which is useful for eating a wide variety of foods: fruits, seeds, roots, even harder items. That kind of flexibility is something humans rely on even today. Its facial structure, too, didn't look exactly like chimps or gorillas, but had its own unique mix. Of course, not everyone agrees. Some scientists think Ouranopithecus might have been more closely related to African apes like gorillas. Others suggest it could have been its own side branch, not directly connected to us at all. The debates get pretty intense. That's what happens in science. New evidence leads to new arguments, and every fossil discovery shifts the conversation. Still, the idea that a Miocene ape in Europe could be so close to us is both exciting and a little unsettling. For a long time, the story of human origins has been centered in Africa. After all, that's where the earliest hominin fossils, things like Australopithecus, were found. But Ouranopithecus in Greece seems to whisper another possibility: maybe the roots of our story stretched beyond Africa, into Europe as well. Maybe the ancestor that started it all wasn't only African, but part of a broader migration that included southern Europe. It's strange to think that the land I picture when I imagine Ouranopithecus hills and forests of ancient Greece might have once held apes that shaped our future. Today, we think of Greece as the birthplace of philosophy, democracy, and history. But millions of years before Plato or Socrates, it might have been home to an ape whose descendants would one day invent philosophy itself. That connection across time gives me chills. What's even more interesting is how Ouranopithecus forces us to think about survival. It wasn't living in the easiest environment. By the late Miocene, climates were drying, and many ape species were struggling. Forests were disappearing. Grasslands were spreading. Apes that had once thrived on soft fruits were running out of options. Ouranopithecus, with its strong jaws and thick teeth, seemed like a survivor, a species tough enough to handle change. Maybe that toughness was exactly the kind of trait needed for the line that would eventually lead to humans. I sometimes imagine an Ouranopithecus sitting under a tree, chewing slowly on a tough piece of food, while the sun beats down on the dry landscape. To us, it might look ordinary. But in that stubborn survival, in those jaws grinding down food that other apes couldn't handle, there's something heroic. It's like watching the ancestor of resilience itself, the kind of resilience that would one day let humans cross deserts, climb mountains, and survive ice ages. And yet, like so many Miocene apes, Ouranopithecus didn't last. By the end of the epoch, its kind disappeared. The reasons aren't entirely clear, maybe changing climates, maybe competition, maybe both. But its fossils remain, scattered in rocks in Greece, silent reminders of a species that lived at the crossroads of our story. So is Ouranopithecus the ape that might have started it all? Some scientists would say yes, or at least, it's one of the strongest candidates. Its similarities to early humans make it more convincing than Proconsul or Dryopithecus. But others would caution against jumping to conclusions. Evolution isn't a straight line, and the Miocene was full of experiments. Maybe Ouranopithecus was close to our line. Maybe it was just a cousin. The mystery stays unsolved. For me, though, Ouranopithecus feels like the kind of suspect you can't ignore. Its powerful jaws, its survival in tougher environments, its similarities to us, all of that makes it impossible to rule out. If Proconsul was the first suspect, and Dryopithecus was the dramatic twist, then Ouranopithecus is the one that makes you lean forward and wonder, is this it? Is this the one? And that's what makes the mystery so captivating. Because even as scientists debate, and even as new fossils are found, the possibility lingers that in the dry forests of late Miocene Greece, an ape lived that carried the spark of humanity. When you follow a trail of suspects in a mystery, sometimes you find one that looks like they don't quite fit, but then again, maybe they do. That's exactly how I think of Sahelanthropus. It's not as famous as Ouranopithecus or Proconsul, but when its fossils were uncovered, they left scientists staring. Because Sahelanthropus's face didn't just look like an ape's. It looked almost exactly like an orangutan's. The name itself gives away where it was discovered. Sahelanthropus comes from Shiva, the Hindu god, because its fossils were first found in India and Pakistan during the 19th century. Later, more were discovered in Nepal and other parts of South Asia. To me, it feels incredible that the dry hills and river valleys of those regions once held apes that might have been central to the story of human origins. Sahelanthropus lived around 12 to 8 million years ago, overlapping with Ouranopithecus in time. But its world was different. South Asia during the late Miocene wasn't the lush jungle we think of with orangutans today. Instead, it was a mix of forests and open habitats, changing with the climate shifts of the time. Sahelanthropus had to adapt, just like the other apes of its era. What stood out most were the fossils of its skulls. Imagine looking at the bones of a face that lived nearly 10 million years ago and realizing it looks shockingly familiar. Sahelanthropus had a flat face, oval-shaped eye sockets, and a narrow nose bridge, features almost identical to those of orangutans. If you put a reconstructed Sahelanthropus face next to a modern orangutan, you'd probably think they were siblings. But here's where things get tricky. While the face screamed orangutan, the rest of Sahelanthropus's body didn't match. Its jaws, teeth, and even parts of its skeleton suggested something different. Instead of being built entirely like an orangutan, Sahelanthropus showed features that overlapped with other apes, two features some scientists argue bring it closer to the human line than its face alone suggests. I like to picture Sahelanthropus in its environment. It climbs through trees, but not with the same smooth swinging motion as gibbons or agile orangutans. Instead, it moves more cautiously, using both its arms and legs to steady itself. When it comes down to the ground, it knuckle walks a little like a chimpanzee might today. On the forest floor, it picks through fallen fruits, nuts, and seeds, cracking some open with its strong teeth. Its world isn't endless rainforest, but scattered patches of woodland where survival depends on being able to eat a wide variety of foods. This brings me to one of the most important things about Sahelanthropus, its diet. Fossil teeth show it had relatively thick enamel, which is great for grinding harder foods. That puts it in a similar category to Ouranopithecus survivors who could eat more than just soft fruits. That kind of flexibility would have been crucial in a time when the climate was shifting, and resources weren't always reliable. But still, the that orangutan-like face made scientists stop in their tracks. For years, people debated, was Sahelanthropus the direct ancestor of orangutans? Or was it closer to humans? Or maybe both shared a common ancestor around that time? The evidence leans heavily towards Sahelanthropus being tied to orangutans. In fact, many scientists now agree that Sahelanthropus is part of the lineage that led to modern orangutans. If that's true, it means that during the Miocene, Asia wasn't holding the ancestors of humans but the ancestors of orangutans instead. And yet, here's the fascinating twist: even though Sahelanthropus might not be our direct ancestor, its story still shapes the bigger picture of human evolution. Because it shows us that the Miocene wasn't about just one lineage moving toward humans. It was about multiple experiments, different apes in different regions adapting in their own ways. While Africa and Europe had proconsul, Graecopithecus, and Ouranopithecus, Asia had Sahelanthropus, each testing out survival strategies in their environments. Some of those lineages ended in extinction. Some, like Sahelanthropus, left descendants that are still alive today, the orangutans swinging through the forests of Borneo and Sumatra. That thought always amazes me. When I look at an orangutan in pictures, with its wide face and calm eyes, I realize I'm not just looking at a modern ape. I'm seeing the shadow of Sahelanthropus, an ape that lived 10 million years ago. Orangutans are like living time capsules, carrying traces of the Miocene inside them. And here's another thing. The survival of the orangutan lineage tells us something important about evolution. It wasn't always about moving toward humans. Evolution doesn't have a single goal. Sahelanthropus shows us that while some apes evolved toward becoming us, others took a different path, and some of those paths are still alive today, reminding us of the diversity of life that once existed. But of course, there's still debate. Some scientists argue that Sahelanthropus's skeletal traits, like its body proportions, don't quite match orangutans either. Maybe it was a close relative, not a direct ancestor. Maybe the real ancestor of orangutans hasn't been found yet. That uncertainty keeps the story alive. I like to think of Sahelanthropus as a puzzle piece that looks like it should fit in one spot, but when you try to place it, the edges don't match perfectly. It looks like orangutans, but not entirely. It has traits that suggest something broader. It sits in that in-between zone, where science can't give one neat answer. And maybe that's the point. The Miocene wasn't neat. It was messy, experimental, full of branches and possibilities. Imagine a family tree with many twisting lines. In Africa and Europe, some of those branches would one day lead to humans. In Asia, Sahelanthropus's branch would stretch toward orangutans. Other branches would break off and vanish. Altogether, they made a forest of apes, each one shaping the future in ways we still struggle to understand. For me, Sahelanthropus adds an important lesson to the story, that human origins aren't just about us. They're about the wider picture of ape evolution. To understand how we came to be, we also have to understand how orangutans, gorillas, and chimps came to be. Each Miocene ape helps fill in part of that bigger puzzle. So, was Sahelanthropus the one that started it all? Probably not. It seems more likely it was the ancestor of orangutans, not humans. But that doesn't make it less important. Because if Sahelanthropus hadn't survived in Asia, if its descendants hadn't carried on, the world today would be missing one of its most remarkable apes. Orangutans wouldn't exist. And without them, our own story of evolution would feel lonelier, less connected, less rich. In a way, Sahelanthropus teaches us that the Miocene wasn't just humanity's origin story. It was the origin story of many living apes. We're not alone in being shaped by that time. We share it with orangutans, gorillas, and chimps, all of whom had ancestors walking the earth in the same ancient days. When I think of Sahelanthropus, I don't imagine it as a failed ancestor or a side branch. I imagine it as a proud figure in the Miocene forest, carrying the torch of survival that would one day glow in the eyes of orangutans. Its face may look different from ours, but its story is still part of the grand mystery. When you listen to stories about ancient times, there's always a part where the mood shifts when abundance turns to struggle, and only a few make it through. That's exactly what happened to the apes of the Miocene. For millions of years, they had ruled the forests of Africa, Europe, and Asia. They were everywhere, climbing trees,